I'm not the one saying this. It's coming from the latest NASA report. It's written in black and white. They are 99.7% certain that they've detected gases on this planet that only living marine microbes can emit. You heard that right. 124 light-years away in the deep abyss of space. Our $10 billion creation, the James Webb Space Telescope, has been locked onto a wild, turbulent alien ocean. It has genuinely caught the scent of a fish market. This isn't just some made-up Hollywood sci-fi script. This is a major bombshell that the world of astronomy has just dropped. 99.7%. In cold, hard statistics. That's called 3 sigma, which means this signal is definitely not a telescope glitch. The chance of it being an error is a measly 3 out of 1,000. In other words, there really is something out there, and that something is pumping out gas like crazy. Today, I'm going to show you the planet that has been driving the world's top scientists absolutely crazy. K2-18b. First, let's talk about what this planet looks like. K2-18b has 8.6 times the mass of Earth. And its radius is 2.6 times that of Earth. Its density sits right between Earth and Neptune. Scientists have given this type of planet a name. They call it a sub-Neptune or a water world. That's not a metaphor, it's literal. The entire planet is highly likely to be an ocean from top to bottom. No land. No mountains. It's just one massive water balloon, hanging silently in the cosmos. And the location of this water world is incredibly unique. It sits perfectly within its host star's habitable zone. And what exactly does habitable zone mean? It's that distance, not too far, not too close, from a star. The temperature is just right. That sweet spot where liquid water can stably exist. Too close and the water all evaporates. K2-18b sits right in the middle of that zone. The star it orbits is called K2-18. It's a red dwarf. Red dwarfs are the most common type of star in the universe. They're small, cool, and dim. But their lifespans are incredibly long. They can burn for hundreds of billions of years. Over 70% of the stars in the Milky Way are red dwarfs. This means that in the universe, planets like K2-18b, orbiting red dwarfs, might be more numerous than we could ever imagine. In other words, K2-18b isn't some rare outlier. It might just be one of countless water worlds that we just happened to discover. This planet was first discovered in 2015 by NASA's Kepler Space Telescope. The moment it was discovered, scientists had only one reaction. There's something strange about this planet. Then, in 2019, the Hubble telescope turned its lens toward it and found water vapor in its atmosphere. Take note, this was the first time in human history that we found water molecules in the atmosphere of an exoplanet within the habitable zone. The first time. In the entire history of humanity, the very first time. The scientific community went into a frenzy. The excitement died down quickly. Because having water vapor doesn't mean there's life. Mars had water in the past, too. Now, it's just a dead, red desert. Having water is just the entry ticket. It's not the finish line. So we kept waiting and kept watching. Then, in September of 2023, the Webb telescope stepped in. What kind of caliber are we talking about with Webb? It cost $10 billion. Its mirror is 6.5 meters in diameter. That's 7 times the size of Hubble. It is the most powerful optical instrument humanity has ever sent into space. How does it actually analyze the atmospheric composition of a planet? It works like this. When K2-18b passes in front of its host star, the star's light travels through K2-18b's atmosphere before reaching Earth. Different gas molecules absorb different wavelengths of light. By analyzing these absorbed light spectra, Webb can figure out what's in that planet's atmosphere. It's just like looking at white light through a glass of colored water. The color of the light changes, and you can tell what's inside the water. Webb used this method to take a good look at K2-18b, detecting methane and carbon dioxide, plus something that brought the whole room to a silence. Dimethyl sulfide, or DMS. What the heck is DMS? It's that exact smell you get at a seafood market. One of the main components of that fishy odor. Where does DMS come from on Earth? It's produced by living things like marine plankton and algae as a metabolic byproduct. As marine life eats, breathes, and goes about its day, it naturally releases DMS into the atmosphere, which is what creates that pungent, nose-wrinkling smell. But the signal from 2023 wasn't quite strong enough. Scientists said it might be there, but they weren't sure yet. So, they kept observing. Then came 2025. The latest report from April is finally out. This time, Webb didn't just detect DMS again. It also found something else. Dimethyl disulfide, or DMDS. Seeing both DMS and DMDS gases appear together in the atmosphere of the same planet, on Earth. Both of these substances are waste gases produced by marine microbial activity, any non-biological process that could create both of these gases at once is extremely rare, almost to the point of being negligible. Plus, having both gases appear simultaneously is much harder to explain away as a mere coincidence. And this detection has a confidence level of 99.73%. But there's one thing I have to make perfectly clear here. Otherwise, those headlines are going to lead you down the wrong path. That 99.7% refers to the statistical confidence of the signal itself. It is not the probability that alien life actually exists. Those two things are worlds apart. Let me put it this way. Imagine you're in a sealed room, and you smell seafood. A 99.7% confidence level just means the smell is definitely real. It means your nose isn't playing tricks on you. Whether that smell is actually coming from seafood, or someone just sprayed some seafood-scented perfume, or maybe some chemical reaction is creating a similar odor, we know the smell is real. But what it actually is, we still don't have an answer. More importantly, a 3 sigma level is nowhere near enough in the scientific community. There is an ironclad rule in astronomy and physics. For a discovery to be officially confirmed, it must reach a 5 sigma level. That's a 99.999% confidence level. The margin of error is only 1 in 3.5 million. 3 sigma and 5 sigma. They might sound close, but in reality they are worlds apart. 3 sigma means 3 errors in every 1,000 attempts. 5 sigma means 1 error in every 3.5 million. This isn't just a small difference. This is a difference of 3,500 times. Back when scientists discovered the Higgs boson, thousands of physicists around the world, at the Large Hadron Collider in Geneva, spent nearly 50 years of theoretical work and 10 years of experiments. And only after the signal hit 5 sigma did they officially announce the discovery. When finding gravitational waves, the scientists at LIGO also waited until it hit 5 sigma before they dared to hold a press conference. It's not just that they're being cautious. That is simply the rule of the game in science. If it hasn't reached 5 sigma, it's all just considered a candidate. All are considered possible. But this time, K2-18b only has a 3 sigma level. It's still a long way from 5 sigma. So, the current conclusion from scientists is, this is, to date, the signal detected by humanity. That is most likely to point toward extraterrestrial life. Pay attention to every word. Most likely. Candidate signal. It's not confirmed. It's not verified. It's not a done deal. We still need more observations. We still need independent verification. And we still need to rule out all other possibilities one by one. Only then can we move toward 5 sigma. The Webb telescope is still keeping a close eye on K2-18b. Further data is still being analyzed. How much longer this road will be, no one knows. Just think about it. Right now, for the first time, humanity has, at a distance of 124 light-years away, on a planet we have never visited, detected in its atmosphere 2 types of gases that, on Earth, can only be produced in large quantities by living organisms. From humanity's discovery of the first exoplanet in 1995, to finding water vapor in a habitable zone in 2019, to catching a faint trace of DMS in 2023, to locking onto both DMS and DMDS in 2025. With a confidence level of 99.7%, every step brings us just a little bit closer than the last. 124 light-years away. In that alien ocean with no land. Who knows if there is something quietly living at this very moment? Completely unaware of our existence. Unaware that a $10 billion machine is staring intensely at the sky above it, trying to find evidence of its existence in its waste gases. 3 sigma isn't enough, but this is the closest humanity has ever come. Maybe the next time will be 5 sigma.